Assalamualaikum and hi everyone. In this video, we are going to learn about Chapter 6, Benzene and its derivatives. There are three subtopics in this chapter: 6.1 Introduction, 6.2 Nomenclature, and 6.3 Chemical Properties. Let's start with 6.1 Introduction, Video 1. As the learning outcomes, you should be able to describe aromaticity, calculate structure and resonance structure of benzene. Benzene is an organic aromatic compound with many interesting properties. Benzene-derived products are well known to be pleasantly fragrant. For this reason, organic compounds containing benzene rings were classified as being aromatic. Aromatic compounds are the unsaturated compounds having one or more planar rings of atoms with alternate single and double bonds. These compounds have unique stability known as aromaticity. The word aromatic means odorous. Many aromatic compounds have an odor, but not all odorous compounds are aromatic. Aromatic compounds are generally nonpolar and unreactive. They are immersible with water, but may be used to dissolve other nonpolar compounds. Aromatic compound is a cyclic conjugated molecule or ion that is stabilized by pi electron delocalization. It is characterized by substitution reaction. Benzene is the simplest aromatic compound. It is a hexagon with alternating single and double bonds. Calculate structure of benzene. Benzene is an organic chemical compound with the molecular C6H6. In 1865, Auguste Kekule was the first to formulate a reasonable representation of benzene. The first structure is represented as expanded structure. From this structure, we can see that the carbon atoms of benzene ring are in the ring, that they are bonded to each other by alternating single and double bonds. One hydrogen is attached to each carbon atoms, or the second structure of benzene represents a skeletal hexagon with 3 pi bonds. In 1928, X-ray crystallography of benzene determined that all carbon-carbon bond lengths in benzene are of equal length. The carbon-carbon bond length in benzene is 1.4a. It is intermediate between single and double bond. This is equivalent resonance structure of benzene, but it is not an equilibrium. Hybrid of these two forms sometimes drawn like this. This structure satisfied the requirements of the structural theory that carbon atoms form 4 bonds and that all the hydrogen atoms of benzene are equivalent. However, calculate structure can't explain why benzene molecules are not undergoes addition reaction. Resonance structure of benzene. In 1930s, Linus Pauling introduced the concept of hybrid orbital and resonance. The bond angles of the carbon atoms in the benzene ring are 120 degrees. The carbon atoms are sp2 hybridized and the 6 overlapping p orbitals form a set of 3 delocalized pi bonds. As a result, the resonance structure of benzene is a hybrid resonance from two calculate structures as shown below. This means that the structure of benzene is neither structure 1 nor structure 2 in A, but it is an intermediate between both structures. The notation of 3 pi bonds can be replaced with an inner ring circle as a resonance hybrid in B. The resonance hybrid in B is more stable than hybrid resonance structure in A. Each sp2 hybridized carbon atom has an unhybridized p orbital perpendicular to the ring. The unhybridized p orbital overlap to form pi electron cloud above and below the plane of the molecule. The circle represents the 6 pi electrons distributed over the 6 atoms of the ring. The 6p electrons completely delocalized around the ring, and we can see that all 6 carbon atoms and 6p orbitals are equivalent. The criteria for aromaticity. Aromaticity is a cyclic conjugated organic compounds such as benzene that exhibit special stability due to resonance delocalization of pi electrons. There are 4 structural criteria must be satisfied for compound to be aromatic. 1. The compound must be cyclic. 2. Completely conjugated. 3. Contain 4n plus 2 pi electrons, where n is equals to 0, 1, and 2 above that obey Huckel's rule. And 4. Planar. The molecule must be flat, usually true if conditions 1, 2, 3 are met. Criteria 1. Aromaticity is cyclic. Is there a ring? If yes, move to criteria 2. If there's no ring, it is not a cyclic compound. Structure 1. Benzene is an aromatic. 2. 135 hexatrene is not aromatic. 3. Pyrrole is an aromatic. 4. Not aromatic. 5. Trophylium ion is an aromatic. 6. Not aromatic. Just to be clear, not all cyclic molecules are aromatic. For example, 7. Cyclohexene is not aromatic, and 8. Tetrahydrofuran is not aromatic. Criteria 2 aromaticity is completely conjugated. There must also be a continuous ring of p orbitals around the ring that build up into a larger cyclic pi system. Tips is only sp2 hybridized carbon present. Structure 1 is an aromatic, all ring atoms conjugated. 2. Not aromatic, nitrogen atom is not conjugated. 3. Aromatic, all ring atoms conjugated. 4. Not aromatic, carbon is not conjugated, which is sp3 hybridized. 5. Aromatic, all ring atoms conjugated. 6. Not aromatic, carbon is not conjugated. 7. Aromatic, all ring atoms conjugated. And 8. Not aromatic, carbon is not conjugated. Key thing to watch out for: an atom attached to 4 bonds. Example, sp3 carbon or nitrogen. Criteria 3 for aromaticity is contain 4n plus 2 pi electrons, where 4n plus 2 is a formula describing the number series 2, 6, 10, 14, 18, 22, and 26 above. These are magic numbers for aromaticity. The number of pi electrons in the molecule must be in the series in order for the molecule to be aromatic. We often call numbers in the series as Huckel's numbers. Structure 1, 6 pi electrons. 2, 6 pi electrons. 4, 2 pi electrons. 5, 10 pi electrons. 6, 6 pi electrons. 9, 10 pi electrons. 11, 6 pi electrons. And 12, 10 pi electrons obey criteria 3 for aromaticity, while structure 3 for pi electrons, 7, 8 pi electrons, 8 for pi electrons, and 10 for pi electrons are not obey criteria 3 for aromaticity. Another way of saying the same thing is the number of pi electrons is equal to an odd-numbered pair. 1 pair, 3 pairs, 5 pairs, and 7 pairs above. This is also produces the series 2, 6, 10, and 14 above. Example 1. Aromatic compounds with one ring is benzene and cyclooctatetraene. Benzene is a cyclic compound, completely conjugated, contains 6 pi electrons, is an aromatic, while cyclooctatetraene is a cyclic compound, completely conjugated, contains 8 pi electrons, which is not obey criteria 3, is not an aromatic. Example 2. Aromatic compounds with more than one ring is naphthalene. Naphthalene is a cyclic compound, completely conjugated and planar. Naphthalene contains 2 rings, so N is equals to 2. Based on Huckel's rule formula, 4N plus 2 pi equals to 4 times 2 plus 2 pi equals to 10 pi electrons is obey Huckel's rule. Another example. Determine either a compound that has 12 pi electrons is an aromatic compound. Based on Huckel's rule formula, 4n plus 2 pi, where n is an integer 1, 2, and 3 above. When n equals to 1, 4 times 2 1 plus 2 pi equals to 6 pi electrons. When n equals to 2, 4 times 2 plus 2 pi equals to 10 pi electrons. And when n equals to 3, 4 times 3 plus 2 pi equals to 14 pi electrons. So, 12 pi electrons is not an aromatic compound. Thanks for watching.